Hello everyone, welcome to my another new video where I will be teaching you integration, and this will be the basics of integration, and this is the part 1 where mainly I will be discussing about the integration of algebraic expressions. Now if we differentiate a function, let's say f of x, let's say we get g of x. Now if we integrate this g of x, we will get f of x. For example, if we differentiate x, we get 1, right? Now if we integrate 1, we will get x plus c. Now what is this c and why do we add this c? First tell me, what is the differentiation of x squared? 2x, right? Now what is the differentiation of x squared plus 3? It's also 2x, right? What is the differentiation of x squared minus 5? It's also 2x, right? So if we now integrate this 2x, which function will we get? Obviously we will get this first function, right? But among these three, which one should we choose? Since we cannot choose any one of them, so to express the part after x squared, that is the constant part, we write c. That's why if we integrate 2x dx, then we get x squared plus constant. That's why we write the c after any integration in this chapter. Now let's see some formulas. These are the formulas which we may need in this chapter. For example, integration of x to the power n dx equal to x to the power n plus 1 divided by n plus 1. Integration of 1 equal to x. Integration of 1 by root over x equal to 2 root over x. And with all the expression, we need to add plus c, right? I just discussed it a while back. Integration of 1 by x equal to ln x. Integration of 1 by x square equal to minus 1 by x. In this kind of problems, we can also use this formula, integration of x to the power n, because if you simplify it, you will get integration of x to the power minus 2, right? If you use this formula, you will also get minus 1 by x. And integration of 0 is constant. Integration of e to the power x is e to the power x. Integration of a to the power x equal to a to the power x divided by ln a. And integration of e to the power ax is equal to e to the power ax divided by a. And here are some trigonometric parts, differentiation of integration of which also gives these things. Let us discuss it later, since in this video we will be mainly discussing about the integration of algebraic parts. So let's go to solve some problems. So type 1 is basically our algebraic expression which we will integrate. These are the 9 problems which I will solve now. So let's look at our first one, where it is integration of x to the power 5 dx, and we can see that we can apply the formula x to the power n, right? Because here n equal to 5. So according to our formula, integration of x to the power n dx equal to x to the power n plus 1 divided by n plus 1 plus c. So if we integrate x to the power 5, we get x to the power 5 plus 1, which is equal to 6, divided by 5 plus 1, which is equal to 6. And lastly, we have to write plus c. Now let's go to our second example, where it is integration of 1 by x squared dx. Here, if you consider this x square, you can also write it as x to the power minus 2 dx, right? Then you can just use the formula dt integration of x to the power n, which is equal to x to the power n plus 1 divided by n plus 1. Again, we have also another formula, integration of 1 by x square dx equal to minus 1 by x. So from there you can also write it directly. Now let's go to our third example, integration of cube root x dx. We know that if there is cube root, we can write it as power 1 by 3. So it will be x to the power 1 by 3. Now we can just apply the formula x to the power n, right? Where n equal to 1 by 3. So according to our formula, it is x to the power n plus 1 divided by n plus 1. So n plus 1 is 1 by 3 plus 1 divided by 1 by 3 plus 1. So we got x to the power 4 by 3 divided by 4 by 3 plus c. And let's go to our next example. I hope you can now solve it. Integration of cube root x minus 1 by cube root x. Now let's simplify it a bit. We know if there is cube root x, we can write it as x to the power 1 by 3. Now since in this part it is 1 by cube root x, so we can write it as x to the power negative 1 by 3. As we know, if it is in the denominator, we can write this power as negative. Now let's integrate. We can again use the formula integration of x to the power n equal to x to the power n plus 1 divided by n plus 1. So we just applied that formula here. In this part, the n's value is 1 by 3, and in this part, n's value is minus 1 by 3. So that's what we got. So next, go to our next example 5. So In example 5, we can see integration of x minus 3 whole square divided by root x dx. Now we can see that we can apply the formula a minus b whole square, right? So if we apply the formula here, we get x square minus 2 into 3 into x, which is equal to 6x, plus 3 square, which is 9. And since there is root, so we can write it as power 1 by 2. Now let us just separate these three parts. We can write it as x square by x to the power half minus 6x by x to the power half plus 9 by x to the power half. Since here is x square divided by x to the power half, so we can apply this formula a to the power m divided by a to the power n equal to a to the power m minus n. So x to the power 2 minus half, then x to the power 1 minus half, then x to the power 1 minus half. So we got these things. Now let us integrate these things by applying the formula x to the power n. Similarly, by applying the formula x to the power n, we got x to the power n plus 1. Here n's value is 3 by 2, and here we applied the formula again, and here n's value is half, and here n's value is minus half. So if you simplify, we just get this thing. Now let's move to sixth example, x to the power 7 plus x square divided by x 5. And we know we can separate this thing like our previous math this way. So we can write it as x to the power 7 divided by x to the power 5 plus x square divided by x to the power 5. Now we can like our previous formula, a to the power m divided by a to the power n equal to a to the power m minus n. We can write it as x to the power 7 minus 5 plus x to the power 2 minus 5. So we got x square plus x to the power minus 3. Now we can just apply the x to the power n formula again, and so we got x to the power n plus 1. So 2 plus 1 equals 3 divided by 2 plus 1 equals 3. Similarly, here n's value is minus 3. So minus 3 plus 1 is equal to minus 2 divided by minus 3 plus 1 is equal to minus 2. Now let's move to our seventh example, integration of 1 plus x inverse 1 plus x to the power minus 2 dx. Now since here is x to the power minus 1, we can write it as 1 by x. Also if we want, you don't need to simplify it this way, or x to the power minus 2, also you can keep it this way to apply the formula x to the power n. But in the middle part, x to the power minus 1, you cannot apply the x to the power n formula, because if you use that, we will get minus 1 plus 1 equal to 0 in the denominator, which will be invalid, right? So we have a formula for x to the power minus 1, which is 1 by x, and which is integration of 1 by x equal to ln x. So we get integration of 1 as x, and integration of 1 by x as ln x, and integration of 1 by x square equal to minus 1 by x. You can use the formula x to the power n, or also we have this formula direct in the formula page. Let's please have a look. In the next example, we see integration of 1 by x into x plus 1 by x dx. Now let's multiply this 1 by x to the inside parts. If we multiply, we get x by x, which is equal to 1, and 1 by x into 1 by x, which is equal to 1 divided by x square. Now integrate 1 and 1 by x square. If you integrate 1, you get x, and if you integrate 1 by x square, you get minus 1 by x. And with all the maths, when you will remove the integration sign, you have to write this plus here. Please don't forget this. Now let's move to our last example, which is integration of 100 x to the power 99. It's very easy. You just have to consider this 99 as n and apply the x to the power n formula. So you get x to the power n plus 1, which is 99 plus 1 equal to 100, divided by 99 plus 1 equal 100 in the denominator. So this 100 and this 100 gets cancelled. So our final answer is x to the power 100 plus c. I'm telling again that please don't forget to write the plus c. So that's it for now. Let's see the type 2 in our next video. Thank you.